This video presents what is projectile motion. The following are examples of projectile motion or two-dimensional kinematics. This video includes the discussion of what is a projectile, characteristics of a projectile motion, horizontal and vertical components of velocity and displacement. A projectile motion is an object upon which the only force acting on it is gravity. It is considered a two-dimensional motion because it is composed of a vertical and horizontal component. Last time we discussed what inertia is. Inertia is the ability of an object to keep doing what it is doing. So suppose a cannon is released on top of a cliff. In the absence of gravity, the cannonball will just continue to move in a straight line with uniform speed. But due to gravity, it falls of about 9.8 meters per second. So, as the object moves horizontally, it also falls vertically. And that is projectile. Projectile motion is composed of two types of motion. The horizontal component is represented by the green-colored ball, while the vertical component is represented by the red-colored ball. Let's describe the horizontal motion or the horizontal component. The horizontal component is the motion similar to a ball rolling freely along a level surface. The horizontal velocity is always constant. The vertical component or the vertical motion is similar to a motion of a freely falling object. It moves due to the force of gravity, and the vertical component of velocity changes with time. The combination of the vertical and horizontal components is the parabolic path of a projectile. The path traced by an object accelerating only in the vertical direction while moving at constant horizontal velocity. Here are the important concepts about projectile. A projectile is any object upon which the only force is gravity. Projectiles travel with a parabolic path due to the influence of gravity. There are no horizontal forces acting upon projectiles and thus no horizontal acceleration. The horizontal velocity of a projectile is constant, a never-changing value. There is a vertical acceleration caused by gravity. Its value is 9.8 meters per second down. The vertical velocity of a projectile changes by 9.8 meters per second each second. And the horizontal motion of a projectile is independent of its vertical motion. It can be understood by analyzing the horizontal and vertical motion separately. The illustration shows a projectile motion of a small ball projected horizontally. The dashed black line represents the path of the object. The velocity vector at each point is in the direction of motion and thus is tangent to the path. The velocity vectors are green arrows and velocity components are dashed. A vertically falling object starting at the same point is shown at the left for comparison. Vy or v sub y is the same for the falling object and the projectile. Let us compare the horizontal velocity v sub x and vertical velocity v sub y of a projectile, released with an initial horizontal velocity of 20 meters per second. Per 1 second interval, you will see that the horizontal velocity is fixed at 20 meters per second, proving that the horizontal component of a projectile is in uniform motion, meaning constant speed in one direction, while the vertical component is changing. Initially, it is 0, then negative 9.8 meters per second. After 1 second, it becomes negative 19.6 meters per second. After another second, negative 29.4 meters per second, and so on. You will see that the vertical component is increasing its speed with a downward direction. Let us describe the displacement of a projectile. As a projectile moves horizontally and vertically, it also covers horizontal displacement and vertical displacement. On the screen, you will see the horizontal displacement and vertical displacement of an object projected with an initial horizontal velocity of 20 meters per second. At 0 second, the horizontal and vertical displacements are 0. After 1 second, 20 meter and negative 4.9 meter. After 2 seconds, 40 meter and negative 19.6 meter. After 3 seconds, 60 meter and negative 44.1 meter. 4 seconds, 80 meter, negative 78.4 meter. 5 seconds, 100 meter, and negative 122 meter, 22.5 meter. What does the negative sign indicate for the vertical displacement? The negative sign means that the object is falling or moving downward. The animation shows the vertical v sub y and horizontal v sub x velocities of a projectile as time progresses. Looking at the animation, you will see the velocity vectors or the arrows representing the velocities of the projectile. Why is it at 6 seconds the vertical velocity is 0? Try to find the answer for this question.